a circuit from an easy square wave generator. And in fact it's a non-stable multi-vibrator circuit. And at the output from that non-stable multi-vibrator circuit we have used another transistor. Want to explain that later. At first the circuit in its completeness without panning and here the pin connections from the transistor that I've used. All BD139 transistors. And the non-stable multi-vibrator circuit can be made with tubes, triode tubes, and also with transistors. And the properties are very simple. An element here and here that's active, it amplifies, could be a tube, could also be a transistor, in this case a transistor. And of course we have to give such a transistor, in this case an NPN transistor, a positive voltage on its base. That's done by this 10K resistor and by this 10K resistor. Not very clearly visible, but anyway. And then these two transistors are made to oscillate by a frequency dependent network between the collector lead from the first and the base from the second transistor. The base is the sensitive electrode and the collector is in general the output electrode. Here we have two 10 nanofarad capacitors, also here 10 nanofarad. Don't bother about this part of the circuit, the resistors. 10 nanofarad here is the central unit, 10 nanofarad here, and that makes that this whole unit starts to oscillate on a certain frequency given by all the properties in the circuit. And this is the frequency that's generated. And it is 9.9 kilohertz. But of course the capacitor here and that capacitor here are frequency dependent. So when you change this capacitor value and that capacitor value, you will find other frequencies. When you take for instance 100 nanofarad here and 100 nanofarad here, the frequency will go substantially down, say to 300 Hertz or so. I don't know that exactly, but test it. This is a way with this potentiometer and that resistor to change the properties from the capacitor. In fact, you are shortcutting it here with this potentiometer. That makes that the RC time, so the frequency time, changes. I've also done that here. And of course when the capacitor is completely shut out, when a wire is here and here, it doesn't function anymore. It's shortcut. But this is a way to change the frequency also, that's clear. And this transistor here is driven into saturation, and we can pull the base frequency to the negative lead. That also has an effect on the frequency, and yeah, that was all. So let's look again to the circuit. Here the first transistor, from the oscillator. Here the second transistor, here the third transistor. It can be pulled up and down to the negative lead by means of this potentiometer. So let's see what happens when we do that. Here now I change the potentiometer value from the second transistor, and you could see the effects. Now I'm gonna change the capacitive value from the capacitor here, that's this one, and that one. Let's see what happens. You can see that the frequency substantially changes. And on the counter, 10.5 kilohertz, 17 kilohertz. So a very substantial change. And with the other cap here, you can get the same, quite the same effects. So anyway, I don't want to make this video too long. This was all to tell. When you want to go to lower frequencies, change the value from this cap and that cap.